This is the third video in a series on solving simultaneous equations. As you've seen from the previous two videos, we have two mantras for solving simultaneous equations. They are eliminate, substitute, check. That's how we go about solving them. And same sign, subtract, different, add. And that tells us which method we need to use in the elimination. This is our first example. And here we have 3x plus 2y equals 8 and 2x minus y equals 3. Now straight away we notice something different about these equations than the pairs of equations we've seen before. And that is neither x's nor y's have the same number of them. Okay, they don't have the same number in front of both the x's or the same number in front of both the y's. Now we can't eliminate until they do both have the same number in front of one of the letters. So the first thing we need to do is to adapt these equations so that they are the same. And the way we do that is to multiply one of them to make it have the same number as the other. And we're going to multiply the second one by 2. When we multiply the second one by 2, we get 4x minus 2y equals 6. We don't do anything to the top one, and we have 3x plus 2y equals 8. Now we have 2 in front of both the y's. So now we can use the method that we already know. And we see we have different signs, so we're going to add. So 3x plus 4x is 7x. 2y plus minus 2y is 0. We've eliminated the y's. 8 plus 6 is 14. So 7x equals 14 and x equals 2. Now we're going to substitute that back into one of our equations. Doesn't matter whether we choose the original equation or the multiplied version. I'm going to use the original, so we're going to substitute this into here. And when we do that, we get 2x, which is 2 times 2, minus y equals 3. So 4 minus y equals 3. So minus y equals minus 1, or y equals 1. Solutions: y equals 1, x equals 2. I'm going to check both of those in the other equation. X equals 2, so we've got 6, 3x equals 6, plus y equals 1, so 2 times 1 is 2, that equals 8, which is what we were expecting, so we've got it right. Here we've got another example, but this time we're going to multiply to make the x's the same. So in the same way, we've got to make the x's the same, so we need to multiply the first one in this case by 5. And that gives us 5x plus 25y equals 25. And 5x minus 3y equals 1, because we don't need to do anything to the bottom equation. Now this is one of the ones that's a bit tricky, because we look at this and we see different signs here, so we think we need to add. The problem is we're eliminating the x's, and the x's have the same sign. They are both positive 5, so they have the same sign, so we are subtracting here. It's very important to remember that you are looking at the sign in front of the letter you are eliminating. So 5x take away 5x gives us 0. We've eliminated the x's, that's good. 25y minus 3y is equal to 25y plus 3y, which is equal to 28y. And that is equal to 25 minus 1, which is 24. So y is equal to 24 over 28, which we can cancel down to y equals 6 over 7. Now we substitute this value back into one of our original equations, and if we substitute it into the first one, we're going to get x plus, well, 5 times 6 is 30 over 7 equals 5. So x equals 5 minus 37ths. And that 5 minus 30 over 7 is equal to 5 over 7. So x is equal to 5/7. Now we're going to check our answers, x equals 5/7 and y equals 6/7 in the second equation. 5 times by 5/7 is 25/7 minus 3 times by 6/7 is 18/7. 25 minus 18 is equal to 7/7, which is indeed equal to 1, as we were expecting, so we are correct. Important thing to remember here, if the number in front of the letter you want to eliminate is not the same, you need to multiply one of the equations so that they do have the same coefficient. The other thing we noticed in this example was that when you're using same sign subtract, different add, you must be looking at the numbers multiplying the letter you are eliminating. So if you're eliminating the x, you do not look at the signs of the y's.